1.7 Transformations. First, we're going to review some parent functions. And parent functions are functions who are basic, fundamental representative of each family of functions. So from the family of the quadratic function, f of x equals x squared, we consider a parent function, and it's a good idea to know what the graphs look like, so we can quickly sketch that. It's a parabola, opens up with vertex at the origin. So this is the quadratic function. F of x equals x to the third. This is a representative from the cubic function, and this is what the graph looks like. F of x equals square root of x. It only takes positive numbers or zero, so it's just in the first quadrant, this graph. And the other parent function, we're gonna talk about it later, but let's use those three. Oh, here's another one, absolute value of x. We call it the v function. So this is not a parabola. This is sharp corner, two broken lines. And of course, we have the identity function, y equals x, that looks like this. Okay, so now we're going to talk about transformations, and first, vertical and horizontal transformation. Example. We want to sketch the following graphs. A, y equals x squared plus 1. So I recognize that the parent function is y equals x squared. I already know the graph looks like this. So this is my parent function. My function has plus 1, which means 1 unit up. So y equals x squared plus 1 will be the same graph, but 1 unit up. B, let's sketch y equals x minus 1 squared. Again, the parent function is still x squared, and I know what the graph looks like. My function will be 1 unit to the right. So here, the red graph is x minus 1 squared, 1 unit to the right. You can check this by mentally plugging in that point, 1, 0. If x is 1, plug it in, y is 0. C, let's graph y equals x plus 2 squared. The same parent function, x squared is the parent function again. But this time your graph is going to be 2 units to the left. So plus 2 means 2 units to the left. So a parent function here, you don't have to graph the parent function each time. You can just translate. Okay, another example where we have to sketch a y equals square root of x minus 1. Now this time the parent function is y equals square root of x, which we know it looks like this. My function has minus 1, which means down 1. So 1 unit down, the same shape and graph. So that will be my new graph. And this point here is negative 1. This is 0. Arrow. B, sketch y equals square root of x minus 1. So the same parent function, but this time we're going to have 1 unit to the right. So y equals square root of x minus 1. 1 unit to the right, so it's going to start at 1 and not at 0. And another example, you can have a combination of more than one transformation. Y equals square root of x plus 3 minus 2. The parent function is still square root of x. The transformation we need to do is 3 units to the left and 2 down. So we start with our parent function. Parent function starts at the origin. So we're going to do 3 units to the left and 2 down right here. And then we'll show the shape of our function. This point here is -3, -2. And it continues. Okay. Now, these so far were vertical and horizontal shifts or transformations. There's also reflections. So, for example, if I have to sketch the graph of y equals -x squared, we know the parent function, but it's going to be upside down. So reflection with respect to the x-axis. Okay, another example would be if you want to sketch y equals square root of -x. Now, we know the parent function is square root of x. Square root of -x will be reflected with respect to the y-axis. Now, because x is negative, -x would be positive. So we have that. Another example, y equals 3 minus square root of x. So there are a few transformations here. We have a reflection and we have up 3. So I'm going to do the reflection first. We can do this step by step. So here is our parent function. Then I'm going to do the reflection. This is negative square root of x. And then up 3 plus 3. So it would be 1, 2, 3, like this. This is the point 3, and this is my final function. So multiple transformations are possible on the same, for the same function. The next type of transformation is stretching and shrinking. So stretching and shrinking. Example, if I have to sketch y equals 2x squared, again, my parent function is still x squared, the quadratic, and I'll sketch it. This is y equals x squared. The 2 in the front means our function is going to grow twice as fast. So it's kind of narrow. And now if I have to sketch 1/2 x squared, starting with the same parent function. So here's the parent function, normal openings. My function be very wide because 1/2 means you're dividing by 2 each y. So another example, we have to construct the function from the given information. So the given function is x squared. Find a formula for g. Find a formula for another function g of x whose graph is the result of f undergoing the following: a vertical shift, up 2 units. So we need to write the equation. We don't have to graph it, just write the equation of g. So g of x would be our function that's given x squared plus 2. That's all. B, reflection across the x-axis. Reflection across the x-axis. So g of x would be negative x squared, so upside down. And lastly, horizontal shift right 1 unit. Horizontal shift to the right 1 unit. So g of x would be x minus 1 squared. And that concludes 1.7.